the resultant of two vectors is perpendicular to one of the two vectors. Now this is the analysis which will find very frequent applications in the numerical problems and MCQ, and if you see if in this analysis we will go for geometric approach, then it will take less than a minute to get the answers. So the scenario is that suppose there are two vectors A and B and the resultant of the two vectors is perpendicular to one of them. Okay, we are not talking that vectors are perpendicular. The resultant of the two vectors is perpendicular to one of the two. So say vector R is vector A plus B and vector R is perpendicular to one of the two vectors, say vector A. Okay, now we know the basic of triangle law. When you apply the triangle law, the two vectors to be added are made in the same order like this, and since they are oriented sequential order head to tail, so this exterior angle would be the vector angle, and the resultant is made by the third side of the triangle taken in the opposite order, something like this. Got it? And we say R subtends an angle alpha with vector A. This is the standard model for triangle law. Now in the present problem, we don't know what is theta. We don't know the angle between the two vectors, but we know what is alpha. Alpha is given to be 90 degree, correct? Because it is given that resultant is perpendicular to one of the vectors, so alpha is known. Since theta is not known, first of all we will make the two vectors A and R. I'm not making B right now. Okay, I'm making an A and R will be drawn tail to tail. Can you see the triangle law figure? So this is your vector A and this is your vector R, and R is given to be perpendicular to A, so this angle is 90 degree. Now you can easily make vector B, because according to triangle law, A and B would be in the same order, correct? So if this is point O, this is point A and this is point B, so what do you think, where would be vector B? So I'll say vector B would be something like this. So this is your vector B. Now you can make the vector angle. You can extend the line of vector A, something like this, and this is the exterior angle. So this will denote the vector angle. So whenever vector R, the resultant of two vectors, is perpendicular to one of the two vectors, we will always make the figure like this. Now we will now apply the basic geometry of class 7th. First of all see, this is a right angle triangle, correct? And hypotenuse is the greatest side. So one thing is for sure, that magnitude of A will be less than magnitude of B. So first point what you can judge is R is perpendicular to vector of smaller magnitude, correct? R is perpendicular to vector of smaller magnitude. So given the problem, the vector F is vector F1 plus vector F2, okay, and F1 is given to be 6 Newton and F2 is given to be 4 Newton, and it is given that the resultant vector F, it is given that the resultant vector F is perpendicular to one of forces. So surely you can say that vector F will be perpendicular to F2. It can't be perpendicular to F1. If it is given to be perpendicular to one of the two forces, surely it will be perpendicular to what? F2, the force with smaller magnitude. So one of the property which we can judge geometry is whenever the vector is perpendicular to whenever the resultant vector is perpendicular to one of the two vectors to be added, it will always be perpendicular to the vector with smaller magnitude. Number 2, perpendicular to one of the vector. Now what do you say about the nature of the vector angle? Surely it will be an obtuse angle, then only the triangle will be completed. So the second property which whenever the resultant vector is perpendicular to one of the two vector angle is obtuse, okay? That means the angle between A and B, theta, will be between 90 degree and 180 degree. It can never be an acute angle. Got it? It can never be an acute angle. This is your second property. Third, you know, the magnitude of the vector is simply the length of the side representing the vector. So in this figure, and vectors are very much, you know, treated geometrically, so you'll simply have to apply the geometric property. So if you apply the Pythagoras theorem, so you'll get AB square is what? OA square plus, this is the third property, plus OB square. So what is AB? The magnitude of B square, OA, the magnitude of A, OB, the magnitude of R. So this is the relation among the three magnitudes. Simply you are applying the Pythagoras theorem. So all the three are related by this equation. And number 4, most important, in many MCQs, we have to find the vector angle. Vector angle means we have to find theta. Finding the vector angle, the problem will give us some relation. Okay, suppose you are given, first of all, we will make the figure like this. This is A, this is B, this is R. Let us do alpha. Of course, alpha will be acute, but alpha is not vector angle. Vector angle is this. But for sure, if you find alpha, you can clearly tell theta. Theta is simply the supplementary angle of alpha. Alpha. This is the base. For this alpha, this is the base. This is the hypotenuse, and this is perpendicular. Now you will find what information is given in the problem, among which pair the relation is given. If the relation is given between base and perpendicular, so apply the equation of which trigonometric equation relate base and perpendicular. The sine is, perpendicular by hypotenuse cos is, base upon hypotenuse tan is, perpendicular by base, so you can apply tan alpha. If the relation is given between base and hypotenuse, you can apply cos alpha. If the relation is given between perpendicular and hypotenuse, you can apply sin alpha, and you can find what? Find alpha. And basically we have to find the vector angle, so it would be simply 180 minus alpha. Got it? An illustration. Suppose we are given R is equal to A plus B, okay, and R is perpendicular to A, and the magnitude of R is half of B. Find angle between A and B. Okay, so first of all we will make the figure. So I'm making first vector and the resultant. That is the way how we draw the figure. This is R, this is A, this is 90 degree. Now I will make vector B, and how will make vector B? Something like this. And this is the vector angle. Let this angle be alpha. Now the problem is saying R is equal to half of B. So if this is X, this will be what? Half of X. Now rest is simple geometry or trigonometry. For this, this is what? The hypotenuse, and this is what? The perpendicular. So it's the sine which relates the perpendicular and hypotenuse, and sine is perpendicular by hypotenuse, so you'll get x by 2, and hypotenuse is x, so you'll get half. And what is the angle for which sine comes to be half? 30 degree. So alpha will come to be 30 degree. But don't do the mistake. Sometimes, you know, in MCQ, you have to find the angle between A and B, and you get alpha is 30 degree, and our option is given to be 30 degree, and you simply mark 30 degree. That is the wrong answer, because this is simply alpha. The vector angle is this angle. So vector angle, because the figure is head to tail, is 180 minus alpha. Theta will be, so it will be 180 minus 30, so it will come to be what? 150 degree. So this is your answer. So you can see geometrically how easily the problem can be done when you are given the resultant of two vectors particular to one of the two vectors. Got it?